Now that we know the connections between the graph of a quadratic function and the algebraic solutions, let's practice this a little more. So what we're going to do is we're going to do problem number 1 together, and the first thing I'm going to do is change problem number 1. I actually worked this out and realized the numbers were just too large for the graph. So we're going to rewrite it, and we're going to use the problem y equals x squared minus 8x plus 12. Okay, so everyone change that on your page too, please. And there's also one other problem I'm going to change, so you might as well just change that right now. So if you scroll down to the bottom of this exact same page, and we are going to make this problem, the third problem, a little simpler also. So cross that out, and let's change that to y equals negative x squared plus 4x plus 5. Just makes it easier to graph. Okay, good. Now that we've gotten that taken care of, let's go ahead and look at that first problem. Now, when you're completing these forms, what you're going to do is you're going to start with the equation, and then you're going to find the y-intercept. Then you're going to factor it and find the x-intercepts. Then you're going to find the axis of symmetry and the vertex. So kind of go in that order for each of these problems. So the first problem is y equals x squared minus 8x plus 12. Now, to find the y-intercept, that means it's crossing the y-axis. So x must be 0. So let's substitute 0 for x. So we get y equals 0 squared minus 8 times 0 plus 12. So then we know the y-intercept is going to be when y equals 12. Now we always write points as an ordered pair. So the ordered pair would be 0, 12. Now let's go ahead and graph that. So as we do it, we'll graph them each time. Oh, I wonder if I go up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, we're going to have to kind of estimate it here, guys. 11, 12. So I'm going to estimate the y-intercept to be there. So that'd be 0, 12. Okay, now factored form. So we're going to take this quadratic equation and we're going to factor it. So are there any factors that multiply to 12 and add to negative 8? So we know it's x and x, and we have y equals. Now 12, let's see, we got 3 and 4, that doesn't make a 7. How about a 6 and 2? Yes, 6 and 2, if we have a negative 6 and a negative 2, that will add up to negative 8. Perfect. Now the reason why we factored it is because we learned in our last video that when we factor it and find the algebraic solutions, those are the roots or the x-intercepts. So when we set it equal to 0, so we're setting y equal to 0, so this will give the x-intercepts. And we're going to have 2 of them. We'll have x equals 6 and x equals 2. Now we always write, these are points, so I always write them as an ordered pair. So it's going to be 6, 0, and 2, 0. So let's go ahead and graph that now. So I go back to the graph, and I'm going to go over 2, 0, and then over 6. 1, 2, 3, 4, 5, 6. Okay, great. Now we know parabolas are symmetrical, so somehow this has got to be symmetrical. Now it looks a little funky right now, I know, because we've got the point up here, and then we have the 2 roots here, so somehow it's got to kind of go like this, but we know the axis of symmetry is a line that divides it in half. And the axis of symmetry will always be in the middle of the roots. Well, how do we find out what is the middle of 2 and 6? Do you remember from middle school, we found the middle by taking an average. So the average then will be 6 plus 2 divided by 2, which is 8 over 2, which is 4. Now we know the axis of symmetry is a vertical line. So if we draw a vertical line, it would be x equals 4. That is the axis of symmetry. Now you'll notice when I draw the axis of symmetry in, I'm just going to draw it as a dotted line because it's not actually on the graph of the parabola. It just shows me where the parabola would fold in half, where it's symmetrical at. Now the last thing we need to do is we need to find the vertex. Now the vertex is always on this axis of symmetry. So the vertex will be on this line, but where? Will the vertex be up here? Will the vertex be here? How do I find out exactly where the vertex is? Well, since we know x equals 4, we're going to take 4 and substitute it into the original equation. And that will tell us the y value when x is equal to 4. So I have 4 squared minus 8 times 4 plus 12. So we get 16 minus 32 plus 12. Okay, let's do some integer work here, folks. 16 minus 32 is negative 16, plus 12 would be negative 4. Now the vertex is a point, so we must write it as an ordered pair. So the ordered pair would be 4, negative 4. So let's plot that point. 4, negative 4, so I go down 4, 1, 2, 3, 4. So here is my vertex. Now remember, a parabola is symmetrical. So if the left side looks like that, the right side must be a mirror reflection. So I know those points are equal, and then I must have another point about right there that is symmetrical. Now if your parabola doesn't look symmetrical, then you need to erase it and redo it. So there is my parabola. So notice we have a vertex, we have an axis of symmetry, and we have roots. One other vocabulary word that I don't think I mentioned in the last video was another vocabulary word is called orientation. Now what that means is when you look at your parabola, is the orientation up? So in other words, is it like this type of a parabola? Or is the orientation down? This type of parabola. Now notice all of the parabolas we've drawn thus far have had an orientation of up. Interesting. Okay, last thing, and then I'm going to let you work a little bit on your own. You answer then the question after the table. How do we calculate the y-intercept? Well, look at your table. Where did we calculate the y-intercept at? Well, we calculated it right here, and we found it by letting x equal 0. So in words, it's important to verbalize our mathematics. How do you calculate the y-intercept? By letting x equals 0, we substitute into the original equation. Because you really understand something if you can verbalize it. So by letting x equal 0, we substitute this number into the original equation to find the y-intercept. Now hopefully your writing's smaller than mine because you need this space for the next problem. There you go. Great. Now with your partner, would you work on the next 2 problems on this page, and we'll check and see how you're doing.